Hello guys, let's continue from where we stopped on our former topic, random variable. Today we are going to look at what? Expectation of a random variable. Expectation of a random variable. Expectation of a random variable. When we talk of expectation, it is something as what they mean in descriptive statistics, but here we include what? The probabilities. So expectation of a random variable is defined as what? The weighted average of all the possible values of the variable together with their probabilities. So let's write it down. Expectation of a random variable. Expectation of a random variable is defined as a weighted average of all the possible values of the variable together with their corresponding probabilities. So expectation of a random variable is defined as the weighted average of all the possible outcomes of all the possible values of the variable together with their corresponding probabilities. Like as I said, expectation of a random variable is the same thing as what? The mean of the variable, but the difference between the mean of a normal descriptive statistics and the expectation of the random variable is that this expectation will include what? The probabilities. So it is defined as, we define it in terms of what? Continuous random variable and discrete random variable. For a discrete random variable, for a discrete case, we define expectation of the random variable as expected value of x, which is also known as what? Mu, is equal to summation over the range of what? X of x p of what? X. So for a discrete random variable, we have that our expectation is equal to what? The mu. This is called mu, which is called the population mean, which is equal to summation as summation over the values of what? X multiply of x, this is the random variable, multiplied by what? Their corresponding probabilities. Now for continuous case, we define expectation of the random variable as expected value of x, which is equal to mu, which is equal to what? Integral over the range of what? X f of x dx. So let's use an example to solve. Let's apply these examples, these formulas, using numerical example. Example 1 if you have example 1, given the table below, this is the table here. We have our x, and this is the corresponding probabilities. This is the value of x, which is 0, 1, 2. We have 1 over 4, 1 over 2, 1 over what? 4. And the question is obtain expected value of x. So solution we have expected value of x is equal to what? Mu, which is equal to what? Summation as x run from what? 0 to what? 2. 0 to what? As x equal to what? 0 to what? 2 of x p of what? X. So we are using this summation because we are dealing with what? Discrete what? Case of the random variable. So what this means, we are summing this x times what? Its corresponding probability. So we come here, this is the values of x, this is the corresponding probabilities. So if you have what? 0 times 1 over 4, we have what? This is equal to 0 times 1 over 4 plus 1 times 1 over 2 plus 2 times 1 over 4, which will give you 0 plus 1 over 2 plus 2 over 4 is equal to 1 over 2, which will give you 1. So the expectation of this random variable is equal to what? 1. So this is for what? Discrete case. Let's solve one example on continuous case. So example 2, given a continuous random variable x with PDF, f of x is equal to what? X over 2, where x is greater than or equal to 0, less than or equal to what? 2. Obtain expected value of what? X. Obtain expected value of what? X. Solution. Now, expected value of x for continuous case is defined as integral over the range of what? X, x f of x dx. So our f of x is what? X over what? 2. So we have, and the range of our x is what? 0, x is greater than or equal to 0, less than or equal to what? 2. So we have integral over the range of 0 to 2 of x times what? Our f of x is x over 2 dx, which will give you, which is equals to integral from 0 to 2 of x squared over 2 dx. So we are going to bring 1 over 2 out from the integration sign because it is what? A constant. So you have what? 1 over 2 integral of what? 0 to 2 of x squared dx. This will give us 1 over 2. If you integrate x squared, you have what? X raised to the power 2 plus 1 all over 2 plus 1. You pass the limit, which is 2, 0. So this will give you x raised to the power 3 over what? 6. Pass the limit, which is 2 and what? 0. So if you pass the limit, you have what? When you put 2 here, you have 2 raised to the power 3 will give you what? 8. 8 over 6 minus 0 over 6, which will give us if you reduce this to its lowest term, you have what? What can divide this and divide this? So you have 2. 2 divide 8, you have what? 4, 3. So our final answer is what? 4 over 3. So the expected value of this random variable given this probability density function f of x to be x over 2 over the range of this x greater than or equal to 0, less than or equal to 2 will give us what? 4 over 3. So let's look at the properties of expectation of a random variable. Properties of expectation of a random variable. Properties of expectation. Expectation of a random variable. Number 1, expected value of A is equal to what? A, where A is a constant. A is a constant. So the expected value of a constant is what? A constant. So if you have 4 and they say you should find what? The expected value of 4. The answer is what? 4, because the expected value of a constant is what? A constant. So number 2, we have expected value of A multiplied by what? A random variable is equal to what? A expected value of what? X. So when you have a constant multiplying a random variable, if you are taking the expectation of that particular function, you have to give what? A constant first multiplied by what? The expected value of that particular constant. Number 3, expected value of ax plus b is equals to a expected value of what? X plus b, because I know that expected where a and b are what? Where a and b are constant. Number 4, variance of a constant is equal to what? 0. So if you have a constant, if you're taking the variance of that particular constant, the answer is what? 0. Now, number 5, when you have a constant multiplying a variable, if you are to take the variance of that particular function, you have what? Variance of ax is equal to what? That constant squared multiplied by what? Variance of what? X. So in our next class, we are going to prove why the variance of this multiplying the constant is equal to what? A squared variance of what? X. Okay, these are the some of the properties of expectation of a random variable. Thanks you and God bless you.